Hello, I am Mohammad Suhail Karkun, currently pursuing Masters in Satellite Technology at the Julius-Maximilians-Universität Würzburg. Today we will discuss about my Seminar Planetary Exploration presentation. So, good morning, ladies and gentlemen. Today we embark on a captivating journey through the lens of innovation and exploration as we develop into the fascinating world of rover camera system. This indigenous electronic eye has played a pivotal role in our quest to understand the mysteries of our planet, Earth, the Moon, Mars, and also beyond. In this presentation, I will uncover the technology behind this camera, explore the stunning visuals they capture, and understand how they enable groundbreaking discoveries in the realm of the space exploration. So fasten your seatbelts as we zoom into the interact mechanics, features, and awesome inspiring imagery that make up the rover camera system. So let's begin our virtual journey through the cosmos. In this presentation, I have included few table of contents, which includes introduction of the rover camera system, importance of rover camera system, components of rover camera system, requirements of rover camera, Mars exploration rover camera configuration and camera functions, camera calibration and their processes, the psi calibration method, and then we will discuss further advancement in rover camera technology. At the end, we will conclude our presentation with a very nice conclusion. For the references, I have also mentioned the references which I have used for making this presentation and enhancing my knowledge. So, what is rover camera system? The rover camera system is a crucial component of space exploration mission, enabling us to capture high-resolution images and videos from the surface of celestial bodies. No signal modality sensor can provide sufficient data to extract all the relevant features of the environment, but camera vision is the most information-rich modality compared to any other sensors. In this image, we can see that Mars 2020 rovers, which has been sent to Mars in the year 2020. Here in the image, we can see that this rover contains several cameras at different positions in front and back and chopper here, and also it contains different low-gain antennas and high-gain antennas. Rover camera primarily serves three functions. First, to support navigation during transverse, to support the development of sample acquisition devices and scientific instruments, and general scientific observations. Here in the image, we can see that on the top we have panoramic cameras and navigation cameras. And at the bottom of arrays, we have hazardous cameras on the front position and back position. And here we have low-gain antennas and high-gain antenna attached on the arrays. Importance of rover camera system. Rover camera provide us with a vital visual data, enhancing our understanding of distinct environment and aiding in scientific research. They allow us to remotely explore hostile and inaccessible regions without putting any astronaut's lives at risk. Rover camera capture stunning images that inspire and engage the public, fostering interest in space exploration more and more. All planetary rovers carries a stereoscopic multispectral camera systems, which has been used for different purposes, from protecting the rover from hazardous or for landing, takeoff, descents, and also for collecting the images and other data from the particular planet. Basically, the rover camera system has different type of cameras based on their purposes. First, let's start with navigation camera. These cameras provide real-time images for navigation and obstacle avoidance during rover movements. Then panoramic camera. Pan camera captures high-resolution, wide-angle image of the surrounding environment, providing a comprehensive view. For nano rovers, pan camera is typically mounted with several limits. The range of the rover should be less than 10 meters. Must camera. These cameras have zoom capability and capture detailed image, allowing the scientists to analyze geological features and potential samples from other planets and other celestial bodies. Spectacular camera. These cameras captures images in specific wavelength, helping identifying minerals and gather valuable scientific data. And at last, we have hazardous cameras. These cameras are mounted basically on the lower part of the rover in front and rear position for protection of rover during its maneuver. So it can be protected from any of the hazards available on that planet like stones and other particles. In this image, we can see that the Mars Exploration Rover Mission 2020-2021. This rover has in total 23 cameras, out of which 9 cameras has been used for engineering purposes, 7 cameras has been used for science, research and analysis purposes, and remaining 7 cameras are used for entry, descent and landing purposes. Here in this image, we can see that in this front and rear position, at bottom we have hazardous cameras. On top, here we have navigation and must cameras. At the front, we have micro contents cameras, and on top we have panoramic cameras. This rover also consists of different antennas, low gain antenna and high gain antenna at the back position here. All the rovers have some requirements. So the requirements of rover cameras. These are the one of the basic requirements which are recommended by scientific visions. Stereo camera should be wide angle and have a minimum resolution of 256 by 256 pixels coded in at least 8 bits per pixel. Stereo camera should be located on the top of mast assembly at the height edge above the ground, where edge should be greater than 1.5 meter to give the maximum view behind the obstacles and the range to 10 meter. The stereo camera baseline should be around 0.5 meter to give a 10 millimeter position accuracy at 10 meter range. Stereo camera orientation should be adjustable along the pan and tilt axis, where 180 degree plus to minus 180 degree is pan and 0 to 90 degree is tilt. Stereo camera should be located as close to the front of the rover along its longitudinal axis to minimize obscuring the front of the rover. Hazardous avoidance camera should be placed on the front side of the body of the rover to emergency stop the rover in case of obstacles. It should be also placed in the rear positions if the rover has to be moved in backward positions if required. Hazardous avoidance camera should have a minimum resolution of 128 by 128 pixels coded in at least 8 bits due to their short range. The localization system should include 3-axis attitude angle of the rover with the accuracy of 1 degree to control camera pan and tilt. Volatile random access memory allocation for the rover navigation system is greater than 3 MB, but 4 to 5 MB would allow additional software enhancement. Non-volatile memory for executable rover navigation code is greater than 100 KB. In this image, we can see that here we have the pan camera must assembly. Here this camera assembly has a plus 180 degree to minus 180 degree pan and 0 to 90 degree of tilt. On the top position of this assembly, we have different cameras attached like navigation camera, must camera, panoramic cameras. Technology of rover camera system. Most rover vision system has been based on solid-state CCD, charge coupled devices, or CID, charge injection devices technology, through complementary metal oxide semiconductors based on APS technology, active pixel sensors technology. CCD image are array of analog shift register in which the electric charge accumulates in proportion to incident light intensity. CCD arrays are fast and robust with high geometric fidelity and very good resolutions. They do not suffer appreciable from distortion, blooming, or any electronic drift. Most CCD cameras comprise with very high pixels of around 1024 by 1024 pixels. Here we have Mars Exploration Rover camera configuration. In this image, this is the 2D image of Mars Exploration Rover side model. Here we can see that in front we have hazardous cameras with a field of view of plus 120 degree to minus 120 degree, and similarly on rear we have rear hazardous cameras with field of view of plus 120 degree to minus 120 degree. On the top of this must assembly we have navigation camera and panoramic camera. Navigation camera have field of view of plus 45 degree to minus 45 degree, and panoramic camera has field of view of plus 16 degree to minus 16 degree. And at end we have high gain antenna and low gain antenna. The configuration of this rover is as follows. Panoramic cameras of 1024 by 1024 pixel CCD cameras with integrated electronics including 8 MB local memory storage. Camera had 48 by 48 degree field of view. Pan and tilt must had 360 degree pan and 68 degree tilt capacity, which is very good and very high compared to any other rovers. Total camera system had a mass of only 360 grams, when the height h is 1.2 meter. Mars Exploration Rover camera functions. The functions of Mars Exploration Rover camera systems are to provide self-localization of the landing site and rover position during the rover transverse, to provide multispectral geological maps of the locality, to provide atmospheric data, and to provide contextual support of other scientific instruments like other sensors, antennas, and all the other scientific instruments which has been attached on the rover. In this table, we can see that Mars Exploration Rover cameras family. The main three cameras, different parameters has been mentioned here. The first camera is navigation camera, then panoramic camera, then hazardous camera. Navigation camera has field of view of 45 degree plus minus 45 degree. Panoramic camera has field of view of plus minus 18 degree, and hazardous cameras has a field of view of 120 degree in total. Resolution of navigation camera and panoramic camera is 1024 by 1024 pixels, and for hazardous camera it is 256 by 256 pixels. And for angular resolutions we have 0.77 mRad per pixel for navigation camera 0.27 mRad per pixel for panoramic cameras and 2.2 for hazardous cameras. The focal length of navigation cameras is 14.67 mm, and the panoramic camera, as I discussed, it requires high resolution, so its focal length is 43 mm. The baseline of navigation camera is 20, and for panoramic camera and hazardous camera it is 28 and 10 cm. The stereo range of navigation cameras lies from 2 to 20 meter. For panoramic camera, it lies from 4 to 70 meter, and for hazardous cameras, it lies from 0.5 to 5 meter. The altitude of navigation camera is 152 centimeter. For panoramic camera, also it is 152 centimeter, and for hazardous cameras, it is 53 centimeter. So from this table family, we can see that panoramic camera possesses very high resolution because it has to collect the data with a high resolution for scientific analysis, and for hazardous cameras, it has very low resolution compared to other two because it has short range and just to protect the rover from any hazardous and obstacles on the planet. Before using the camera on the rover and using the rover on other planets, we require to calibrate the camera. Camera calibration is a crucial process for the rover camera systems, ensuring accurate measurement, distortion correction, and precise image captures. Camera calibration establishes the intrinsic and extrinsic parameters of the camera, enabling accurate measurements and distortion corrections for getting the high-resolution images for scientific analysis. Camera calibration ensures precise mapping, 3D reconstructions, and scientific analysis of the image captured by different rover cameras. It is essential for accurate localization, navigation, and obstacle avoidance, enabling rover to explore planetary surface effectively. It is very important to calibrate the camera accurately and precisely so any problems can be resolved with the images we get, and we can get a very high camera calibrations and resolutions. In this image, we can see that this rover has been placed in the software for camera calibration, and here we can do different camera calibration using the software simulations. Camera calibration process. The process has basically 5 steps: image acquisition, pattern detection, correspondence estimation, camera calibration parameter estimation, and at end validation. Image acquisitions captures a set of calibration images with known calibration patterns such as checkboards from different angles and orientations. So the checkboards or any frame point is required for this acquisition. Then pattern detection. It detects the calibration pattern corners in the acquired images to make a particular frame for the detection. Correspondence estimation. It establishes the correspondence between the detected pattern corners. Calibration parameter estimation. It utilizes optimization algorithm to estimate the intrinsic and extrinsic camera parameters. The algorithm varies depending on how we want to use the camera calibration process. And at end, validations. Evaluate the accuracy of the calibration by reprojecting point on the acquired images, and then we can test the camera calibration process in labs using simulations or in real life using the camera images. There are many methods available for camera calibration, but Tasai calibration method is one of the most used and most common method for the camera calibration. This method has also been used for Mars exploration rover camera system calibrations. The SI calibration method is most widely used algorithm and decomposes the solution for 12 parameters by introducing different constraints. Out of these 12 parameters, we have 9 rotations and 3 translations. This method is autonomous, accurate, effective, and versatile. But only disadvantage is that knowledge of camera pose is necessary relative to the fixed reference frame for the camera calibration. So camera poses and the reference frame is required for this method. In this image, we can see that we have a pinhole model for the intrinsic camera lenses. As we know that there are many further advancements possible in space industries and satellites and also in camera systems. There are many further advancement possible, but there are few areas in which this advancement can be possible most quickly and in a shorter period of time, like high resolution imaging, enhanced optics, robustness and durability, autonomy, and remote operations. High resolution imaging. Nowadays, modern rover camera system can capture incredible detailed image with very high resolutions of several megapixels, enhanced optics, advanced lenses and imaging sensors enables sharper and more accurate image captures for higher resolutions, so scientists can analyze the image more accurately and with lesser simulations. Robustness and durability. Rover cameras are designed to withstand harsh conditions, including extreme temperatures, dust, and radiations. So with the help of high robustness and durability, we can deploy our camera systems and rovers in distinct and very harsh planet weathers. Autonomy. Some rover cameras have AI capabilities to autonomously identify and analyze interesting features or samples. Remote operations. Rover cameras can be controlled remotely from Earth, allowing scientists to adjust settings and capture scientific data. It can be also controlled autonomously using pre-programmed algorithms. Now, at the end, I would like to conclude this presentation with few lines. The rover camera system, coupled with accurate camera calibration, empowers us to explore and study distinct planets. Advance in camera technology continues to push the boundaries of what we can achieve, unlocking new discoveries and captivating the worlds and planets. There is no limit for further research, as we all know that. Calibration ensures accurate measurements and enables autonomous operations and maximizing the scientific potential of mission data with a high amount of data as high as possible, so we can analyze and get more information of different planets. In this image, we can see that ExoMars pen camera prototype and ExoMars mounting bars. This project has been under research by European space agencies. In this image, we can see that we have a high-resolution cameras with field of view of plus 5 degree by minus 5 degree and resolution of 1024 by 1024 color pixels with CMOS detector. We also have pen camera interface unit. We also have panoramic camera or optical bench and with wide angle stereo cameras with a field of view of 34 degree by 34 degree and a resolution of 1024 by 1024 pixels CMOS and 2 wheels with 12 filters each. So here we can see that this project will be more advanced compared to the Mars exploration rover. Now, I would like to show you a small video of Mars exploration rover currently deployed on the planet Mars and their functioning of camera systems so we can understand more about the camera system and rover and the planet Mars. Here we can see that the mast assembly has been deployed with navigation camera and panoramic cameras, and now it is with a pan of 360 degree and tilt of 68 degrees. So here the pan moving has been shown to calibrate the mast assembly camera. And now we can see that very high resolution through these cameras. As we have seen that this video shows that how the camera systems and how the rover functions on different planets, and how the mast assembly, camera calibrations, antennas, and other functions and other sensors has been used and assembled in one rover to perform a different task on different planets. At the end, I would like to give you some references from which I used to make this presentation and also to enhance my knowledge in rover and rover camera systems. For any query and questions, please contact me on this given email address. Thank you very much for watching this presentation and have a nice day.